In this video, we are going to be learning about how the universe looks to us from here on Earth. So this video is called Patterns in the Night Sky. So we usually think of a constellation as a pattern in the sky that the ancients made a name for and made up stories about, but for astronomers it has a more precise definition. It's a region of the sky with well-defined borders, and every point in the sky belongs in some constellation. So for example, in this region here is the constellation of Orion, and the star Betelgeuse is within that region of the sky. There are 88 official constellations, and they were chosen in 1928 by members of the International Astronomical Union. Now, we already know what the celestial sphere is. It was an imaginary sphere that the Greeks came up with. They thought all of the stars were fixed on this sphere and it orbited the Earth. We know now that that's an illusion, but it's still a useful concept. And it's useful because it allows us to map the sky as seen from Earth. Now, there's 4 special points and circles on the celestial sphere. For example, the North Celestial Pole, and that's the point directly over Earth's North Pole. It's right where the star Polaris is. Then there's the South Celestial Pole. That's the point directly over Earth's South Pole. That's where the Southern Cross is. There's the Celestial Equator, which is a projection of Earth's equator onto space and makes a complete circle around the celestial sphere. Last but not least, there's the ecliptic, and that's the path the sun follows as it appears to circle around the celestial sphere once each year. It crosses the celestial equator at an angle of 23.5 degrees. That's actually the tilt of Earth's axis. So these are all important vocab words that you should have in your notes. You may want to pause the video to write these all down. Oh, and one last thing, remember that it's called the ecliptic because along that ecliptic path is the only place where lunar and solar eclipses can happen. So this is a visualization for the vocab words from the previous slide. So the North Celestial Pole, right above the North Pole on Earth, South Celestial Pole, right above the South Pole on Earth, the celestial equator, you can see it's parallel to the equator on Earth, and the ecliptic, which is the apparent path of the sun across the sky throughout the year. We can pretty clearly see the Milky Way on a dark night, and it circles all the way around the celestial sphere. The reason why is this next bullet point here. It traces our galaxy's disk of stars, which is called the galactic plane, as it appears from our location within the galaxy. So our galaxy is kind of shaped like a thin pancake with a bulge in the middle, and here's our location right here. It's a little more than halfway out from the center. And if you look in any direction, we can see the countless stars and vast interstellar clouds that make up the Milky Way. So no matter where you are on Earth, you'll see lots and lots of these stars in the Milky Way. Another important concept is the local sky. So that's the sky as seen from wherever you happen to be standing. It takes the shape of a dome. The dome shape arises from the fact that we only see half of the celestial sphere at any particular moment from any particular location, because the ground will block the other half. The horizon is the boundary between Earth and sky. I don't know if you guys heard that noise, but that's my cat playing. The zenith is the point directly overhead. These are all important vocab words that you guys should have in your notes as well. So the one I just went over, the horizon, divides the sky from the ground. Zenith, that's directly overhead. The meridian is an imaginary half circle stretching from the horizon due south through the zenith to the horizon due north. So this pink line that they've drawn for you here is the meridian. The azimuth, also known as the direction, is the degrees clockwise from due north, and is one of the things that's used to locate an object in the sky. So for example, this person is trying to locate this object right here. Let's just mark that. There we go. So from due north, that object is southeast. Next, we have the altitude, and that's the angular distance between the horizon and an object in the sky. So that's what this 60 degrees is right here. Now there's also angular sizes and distances. So we don't have very good depth perception, so we don't actually know how far away objects really are in space. We don't know their true sizes or separations. However, describing the angular sizes and distances is useful. So the angular size is an angle an object appears to span in your field of view. So as we talked about, the sun and the moon both have an angular size of 0.5 degrees. The sun is 400 times bigger, but also 400 times further away, so they appear to be the same size in the sky. Now, the angular size does not by itself tell us an object's true size, because it depends on distance, but it's useful for describing how objects appear from Earth. The angular distance is the angle that appears to separate two objects in the sky. And astronomers usually use more precise measurements than a degree. So an arc minute is 1/60th of a degree, and an arc second is 1/60th of an arc minute. So here's a better visualization of what I was just talking about. So the moon, the span of the moon in the sky is 1/2 a degree, and then the distance from these two stars in the Big Dipper is 5 degrees, and then the width of the Southern Cross in the sky is 6 degrees. Now there's a pretty handy way to measure distances. You can actually use your hand for it. So what you want to do is when you look at objects in the sky, you want to hold your hand at arm's length and close one eye. So the width of your fist, as shown here, is 10 degrees. The distance between your stretched little finger and your thumb is 25 degrees. You can see the Big Dipper pictured here. The tip-to-tip span between your index finger and your little finger, right here, is 15 degrees. Your 3 middle fingers span 5 degrees, and your little finger is 1 degree. So you can look at the sky and see the span, but just by using your hand. Next, we're going to talk about the rising and setting of stars. So as we know, stars don't actually rise and set. It's the Earth that's spinning. The Earth rotates from west to east, and that causes the stars to appear to rise in the east and set in the west. So Earth rotates that way. It appears that the stars rotate the opposite direction. And we can picture the movement of the sky by imagining the celestial sphere rotating around Earth. So again, that's not what really happens, but it's a useful image. Let's talk about the motion of stars in the local sky. The horizon cuts the celestial sphere in half, so it can get a little more complicated. A circumpolar star or constellation is a star that always remains above the horizon for a particular latitude. So it doesn't matter what time of year it is, it'll always be above the horizon. So in the northern hemisphere, those are stars near the north celestial pole, and they appear to circle counterclockwise around Polaris, which is the North Star, each day. In the northern hemisphere, stars near the south celestial pole never rise above the horizon at all. That makes sense because we're just too far north to be able to see the other side of the celestial sphere. And then all of the other stars have daily circles that are partly above the horizon and partly below, which again means they appear to rise in the east and set in the west. So here's Polaris right here. and all of these constellations will appear to rotate counterclockwise on a daily basis around Polaris. So just the constellations that are closer to Polaris, not necessarily the ones that are further out. So the constellation that appear to you will depend on both your latitude and the time of year. If you travel far north or south, you'll see a different set of constellations than you see at home. And you'll see different constellations throughout the year, even if you stay in one place. So latitude, remember, measures how far south or north you are. So the latitude affects the constellations we see because it affects the location of the horizon and the zenith relative to the celestial sphere. Now keep in mind that the constellations you see do not vary with longitude. For example, where I'm from, Philadelphia, is about the same latitude as we are here in Denver. So even though Philadelphia is much further east, you can see the same constellations there that you would be able to see here because they're at the same latitude. So here's kind of what I mean. Let's go back there for a second. So this bullet point says, it affects the constellations we see because it affects the locations of the horizon and zenith relative to the celestial sphere. So if you're at a latitude of 34 degrees, then the celestial equator is here. Your zenith is here. So this is, and this is at 34 degrees south. So if this is your zenith, then clearly you wouldn't be able to see anything that's down here, because you're just facing this direction rather than the other direction. Another really interesting point is that the altitude of the celestial pole in your sky is equal to your latitude. So for example, if you see the North Celestial Pole, so specifically the star Polaris, at an altitude of 40 degrees above your north horizon, your latitude is 40 degrees north. So that's one way that ancient navigators were able to tell what latitude they were at, because they would just look for the North Star and say, oh, the North Star is, say, 50 degrees above, and they could use their hands and other instruments to figure out that degree measure, and they would know what latitude they were at. So constellations also vary with the time of year. And this changes because Earth orbits around the sun, so the parts of the sky that you can see change. As Earth orbits, the sun appears to move steadily eastward along the ecliptic, with the stars of different constellations in the background at different times of year. So the constellations along the ecliptic are what we call the zodiac, and the sun's apparent location along the ecliptic determines which constellations we see at night. So for example, the sun appears to be in Leo in late August, which means that we can't see Leo at night. So here's a picture of what that looks like. So on August 21st, the sun here appears to rise in the constellation Leo. And obviously if the sun is rising in Leo, then it's daytime. So the constellation that we can see at nighttime on August 21st pretty clearly would be Aquarius, because it's on the exact opposite side of the ecliptic. So I hope you have a little bit of a better understanding of how the universe appears from Earth.